Welcome back to Mr. Bresciani's math class. So today we're going to look at 7.4, solving problems involving prisms and cylinders. And what this means is we're just going to look at what we've learned over the past three concepts and apply that to word problems. So our student outcome for today is that after this lesson, I'll be able to solve problems involving right rectangular prisms, triangular prisms, and cylinders. The teacher outcome for this lesson is, after this lesson, I will not have said the words especially or all right more than 5 times. Our first question today is, Kevin is stacking Toblerone bars to make a giant triangular prism. In total, he will stack 64 bars. What is the total volume of this display? So before I explain the answer to you guys can pause it here if you like and try it on your own using the knowledge you've had so far, and just hit play and I'll go through the answer as well. Okay, so let's look at the answer then. So the first thing we've got to do is write out our formula. So we're looking for the volume of a triangular prism. So we're going to have our volume is, and it's always the area of the triangle, which in this case is going to be base times height of the triangle divided by 2 times the height of the prism. So that means that this here is applying to this area here, and this here is applying to the height of the prism itself. So let's fill in what we know. We know that our base of our triangle is 5.6. So we've got 5.6, and never forget the units, so it's centimeters. We're multiplying it by our height of the triangle, not the height of the prism, which is 5 centimeters. Now we're multiplying it by the height of the prism, which is right there, and that is 20 centimeters. When we multiply them together, we have 5.6 times 5 times 20. We get an answer of 280 centimeters, and remember, volume is always in cubes, so centimeter cubed. Now, if it was just a question of the volume of this bar was, we'd be done. But the question clearly states that we're looking for 64 bars. So the next step is just to take that volume, which is 280 centimeters cubed, and multiply by how many we're using. There are 64 bars total, so we're going to do times 64. Our volume then becomes 17,920 centimeters cubed. So there you have it. There's your final answer to this question. Now, let's do a different one here. Let's look at this one. A cylinder with a radius of 0.6 meters and a height of 15 meters needs to be replaced with a cylinder of equal volume. However, the new cylinder has a radius of 0.5 meters. What is the height of the new cylinder? Well, that means, again, we're looking at this cylinder right here, and it's got, like it said, there's 0.6 meters as its radius and 15 meters as its height, and if they replace it with a new cylinder, which is over here, but it has identical volume, what's changing though is the radius. So I'm going to try to find the new height of the cylinder, even though they have the exact same volumes. So what we're going to do is just flip the page here and break this into 4 steps. So step 1, what we're going to do is we're going to try to find the volume of the original cylinder. Now, if you recall from the last page, which I'll show you here, the original cylinder, the radius is 0.6 meters, and the height is 15. So let's take a look at this. We got our formula is volume equals pi r squared times the height of the prism. In this case, the volume is 3.14, which is pi, times 0.6 squared times 15 centimeters, or this is meters, sorry. And I forgot to add my unit there, meters. Sorry, it's a little bit messier here. So if we times 3.14, oops, sorry, a little bit of a blurb there. As I was saying, we're going to times 0.6 times 0.6 because we're looking at a square. That gives us 0.36, and we're going to multiply that by 3.14, which gives us 1.1304, and multiplying that by 15 meters, we get an answer of 16.956 meters cubed. Because again, we had our meter here, and we had our meter square right in there. So that gives us meters cubed. Now we found the volume of that original cylinder. Now we've got to do step 2. Write down what we know for the second cylinder. Well, if you refer back to that second cylinder, it says we know that it's 0.5 meters is the radius, and we don't know what the height is. So, write our formula down again. Well, volume, we know, equals, of the entire cylinder, 16.956 meters cubed. We know that because we just found that right there. The volume of both cylinders are the same, so the volume is 16.956 meters cubed. We know the radius, as it said, is 0.5 meters. The height, we don't know. That's our unknown. We have no idea. So in order to find that height, which the whole question is asking, we've got to put what we know into a formula for step 3. So in step 3, we're going to write out our whole formula again, which is volume equals pi r squared times the height. Well, we know volume, as I said up here, is 16.956. So 16.956 meters cubed equals, on the formula, pi, which is 3.14. We know our radius is 0.5 meters, so it's times 0.5 meters squared times height. So now we've got that, let's just do a bit of work here. We've got 16.956 meters cubed equals 3.14 times 0.5 squared. 0.5 squared is 0.5 squared to 0.25. When we times that by pi, we get a total of 0.785 meters squared, and we're still times the height. That's as far as we can go right now. And to step 4, it says we've got to isolate the unknown, which is our height, by dividing. So when we write this back down again, I've got my 16.956 meters cubed equals 0.785 meters squared times height. Well, right now, this height is attached to this 0.785. We can't just move it. We've got to do the opposite operation. And in this case, I said the height, it is being multiplied. So in order to get rid of that height, we've got to do the opposite operation just like earlier on in the year. To get rid of it, we've got to divide. So if we were to divide this whole thing by 0.785 meters squared, we've also got to do it to the other side, because what you do to one side, you have to do to the other. So on the other side, we're also going to divide by 0.785 meters squared. Now on this side, because we've got 7.85 on the top, multiplying and dividing, it just cancels out, and that becomes 0. On this side, we actually have to do the work. So 16.956 meters cubed divided by 0.785 meters squared leaves us with 21.6 meters. And if you look here, because this is a cubed, and this is really bad too, whenever you divide exponents, you just subtract them. So 3 minus 2 leaves us with just 1 meter, so it's just 21.6 meters equals our height. Now the last thing you can do if you want to double check your answer is put it back in. So if you look at our question, it said, what is the height of the new cylinder? Well, if we know that height is 21.6 meters, let's check it out then. we know the height of our new prism is 21.6 meters. We know the radius is 0.5 meters. And the total volume should be, what did I say? I think it was 16.956 centimeters cubed. Well, let's figure it out then. Pi r squared times height, 3.14, 0.5 squared times 21.6 meters. 0.5 times 0.5 is 0.25. 0.25 times 3.14 gives us on this side 0.785 meters squared, and we're going to times that by 21.6, and guess what? Our total answer is 16.956 meters cubed, which is our answer here, which also answers the volume of the second and first cylinders. So that is how you find out the height of a missing cylinder using these 4 steps. This is a little bit more confusing than we've done before, but just stick with it. If you need to watch this again, feel free to watch this part again and follow along with it. Thanks, and we'll talk to you tomorrow.